Okay, I lied. I'm making a new video, and I'm doing this on my own time just to. I bucked up again, and I'm gonna try to make it work. Fight this computer and see if I win. Okay, so the last day of notes before our quiz Friday, so we'll get a little time for review. Um, Tomorrow, Thursday, and then we're gonna go with the quiz, our first official grade. Let's see how we go. All right. So here's what 2 day 3 is. It's putting all the days together. We did check digit schemes last week, and now we can talk about modular check digit schemes because now we know about mod math. So what's a modular check digit scheme? The check digit is actually the whole number, and looking at example 1 already, that is the check digit. So look at mod 7. So from 0 to 7 minus 1, 0 to 6 could only be what the check digit is for this. That is congruent to the ID number mod M, meaning I'm going to mod M these first 4 digits. So the ID number will be 4329 blank. And the blank in any mod scheme is mod of the previous digits, whatever that answer is, which we know mod means remainder, we put it in that blank. So find the ID number 4329 mod 7. Okay, well, what we do is we got to take 4329. Apologize for my bad writing. And I am going to go fast because this is now on the internet. And you can, if I go too fast, you can just, pause me and then rewind me and listen to what I spoke fast. But of course, this is slow because I'm waiting for the computer to open. Sorry, calculator. Working, working. See it right there, TI Smart View. You can make it. You can do it. Okay, 4329. This is a calculator question because divided by 7, enter. Then one quick way, I could subtract 618 to get just that decimal part. And then you take that decimal and multiply it by 7, which is what many people were doing. So what this means is this is 6. Let me see if I can pull that screen. Yes, I could still do something that I used to be able to do back in the past. Success. All right, I'm so excited. Actually, something I can do. Of course, I can't lasso it, shrink it. Okay, and then move it. All right, I used to be able to do that in the past. Now I can still. All right, so what this means is this equals 6, 8. Those listening at home, you don't understand. Every year, tech department makes everything new, and then us teachers look like buffoons teaching up here because we don't know how to work the equipment. So anyway, the remainder is 3. So when I mod 7 these 3 digits, or these 4 digits before that, the remainder is 3. So that is the check digit. So there's a modular check digit scheme. Whenever they say it's a mod scheme, when it's worded that way, so all schemes noted as a mod number scheme. Could be any number. This one happened to be 7. That means the check digit is equal to mod of all the previous digits. All right, and in this case, 7 does not have a special division rule, so I physically had to divide that number by 7 and then find the remainder. And we know remainder is what mod math is all about. Could do the same exact thing for this one, but then we got to know something that's special about mod 9. So again, the answer is going to be 5, 3, 6, 8, blank. And then whatever mod 9 of the previous 4 digits is, then we can, fill that in. But we know when we divide by 9, there's a special rule about dividing by 9. So this would be a no calc possibility by good old evil Mr. Samuelus. Sarcastic Mr. Samuelus is some people that had Mr. Mraz ran and told him, yesterday. Boy, that guy's really mean. But anyway, I don't think I'm that bad, but that's fine. So we could take this, but on a calculator, that'd be fine. No calculator, then we'd have to do the old division garage thing, and then 5,000 in there, 9 out here. Oh, I hate Mr. Samuels. I got to do all this long math. No, the point of me doing this as a no calculator is to force you to use the special division rule of 9. And if the sum of the digits is divisible by 9, then the number itself is divisible by 9. 8, 14, 22. So now what we have to do is just analyze what's 22 mod 9. Not only does it give you if a number is divisible by 9, but it also gives you the remainder. So 9 goes into 22 up to 18 with a remainder of 4. So if I were to do this and actually do this long division, you would get remainder 4. That's the special division rule of 9. Extended. So 4 goes here. So that's why mod 9 schemes are kind of fun because you can do it without a calculator. All right, I'm going to move on. You can redo that if or relook at that because I'm moving fast. All right. So this isn't really method 3. It's just another way of doing this. Now look at this ID number, and it's a mod 9 scheme. Okay, so denoted. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. The 11th digit is the check digits. All right, so D sub 11, and it is whatever mod 9 of the previous 10 is. That's what a mod scheme is. All right, so we should be able to figure that out. But what does this mean about casting out the 9s? Well, you got to understand even in a previous question, it doesn't matter that I maybe got rid of 6 and 3, because what's 6 and 3? Waiting for an answer from the computer? 9, Mr. Samuelus. So, yeah, it's 9. So what if I just ignored that and ignored this? Well, really what that does is just knock down the sum by a multiple of 9, which is not a big deal because then what would have been left over is 13. So this is what's called casting out the 9s. So when I take out multiples of 9, I'm still going to get the same mod. What I'm doing is taking a cycle out. I think of mod as like cycle math. Like 1,300 hours is 1 o'clock. That's because we go in cycles of 12s. And then after we hit 12, we go back to 1. So 1,300 hours is actually 1 o'clock on our standard clock. Well, when I take out the 9s, then all I'm doing is bumping down the sum. Why would you want to, have that skill? It's because you could, when you start adding more and more numbers, there's more and more possibilities for mistakes. The sum is going higher and higher. Then it's harder to analyze what does 9 go into. Why is he talking like this? But anyway, so imagine a credit card number 16 digits long and it was a mod 9 scheme. It would get annoying. So what you do is picking colors here. Well, I could take that 9 out because all that does is take a multiple of 9 out. I could take that out. This 0 is meaningless. 9, 9. So what I've done is reduce the sum by multiples of 9, which is not going to change what the mod is. I'm taking cycles out. Well, wait, there's more. Okay, I can't guys. Okay, what's 7 plus 2? 9, Mr. Thamulus. So I can get rid of that because that's another multiple of 9. And then 8 and 1. 9. Now again, what's the only reason I could do this? Because there's a special division rule by 9. This long number, I got distracted. Remember my ADD. Got to get rid of this email. There we go. I can't teach, but that's there. Okay. What was I saying? This long number, when divided by 9. Oh, type it on your calculator and then divide it by 9. Get the decimal. Well, actually, division by 9, you could add the digits. And if the sum of the digits is divisible by 9, then the number itself is divisible by 9. So we can only do this on mod 9 and mod 3 schemes. So I'm making that point because of the students last year that had big problems. Huge. Okay? Not only with their behavior, we talked about that in class, but also, just understandably getting things messed up. So if I would have added up all these digits, and I think in one class I did, 9, 18, 27, 36, 45, 54. 54 plus 5 is 59. Guess what 59 mod 9 would be? 5 mod 9. So in order to reduce those out, it made it a lot easier. So the digit is actually 29957091998, and then the check digit is 5. So that's a typical mod anything scheme. The only reason we are doing this special thing is because mod or divided by 9, you can do something special. All right. Now next, banknotes. Now draw a line in your notes. This is a little different. If you read your book tonight, probably won't. Then it moves on from mod schemes to what is out there that uses modular math in the real world. So this is a little bit different than a mod 9 scheme. So I'm going to cross that off because when I say a mod 9 scheme, I want you to know that you mod 9 all the previous digits, then the check digit is mod 9 of what the previous ones are. Banknotes in the Euro banknote system do not work that way 100%. I will say that one more time. They're not a typical mod 9 scheme. They do mod 9, but there's a little minor difference. So I'm only saying that to prepare you. All right, so then when you look at this, you see the serial number. All right, let me check my time. Ooh, 10 minutes, good. All right, that serial number, actually there's an S in front of there. Okay, and actually you can see that up in this typing right here. Psht. Okay, well that S actually means what country it comes from. I have no idea what I just hit there. Okay, as usual. Always fun. Okay, now the letter in front means what country it comes from. So that was an S. So country is Italy, but also it translates to the number 2. So that's one of your jobs. You're going to have to know that that S or whatever letter it is means what country. Not necessarily that, but then it converts to a number. So it must be some little cryptic thing that they want to do to you to, I don't know, make it more special, this little system. Okay. So then, is this a valid banknote? Sorry, I forgot. Wait, you told me this was different than your typical scheme. Here's what it is. Okay, so let's look at this digit. There's a S will turn into a digit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There is 11 previous digits. So let's pretend we have 11 blanks here. Plus the 12th digit, which is the check digit. So that's the same. The check digit is at the end. But here's what's unique with the Euro system. And again, I'm just sharing with you what, according to the book done in 2004, that this is what the Euro bank scheme is. It's not a mod 9 scheme. So you don't mod 9 11 digits and then put that answer there. What the Euro bank system is this is equal to 0 mod 9. So again, they made a decision. I'm just the informant. Don't get mad at me. But when you say mod 9 scheme, they work like what we did on the previous one. The check digit is mod 9 of the previous digits. That's not what happens with a banknote. The check digit makes the sum of the previous 11 digits equal or congruent to 0 mod 9, and I'm done. You got to get that. You've got to be able to understand, okay, that's the information, and I need to get that in my head and do it. Now, I will say this. Included on your cheat sheet for your test will be this, because I'm not going to make you memorize countries of a Europe banknote. What would be the point? So that will be on there. But then also I wrote a sentence down there, or typed it, that remember Euro banknotes are all of the digits, including the check digit, equals 0 mod 9. Okay? Uh-oh, there's a bell. Okay, so first things first, S is Italy, which we already denoted. So this is a 2. Then 0, 7, 0, 9, 0, 5, 4, 6, 4, 9, 8. Don't do a transposing error. Don't do a single digit error. Make sure you're careful on writing your numbers down. And then what we're doing is this valid? So that means I have the 11 digits plus the 12th. And if it is valid according to the specific, unique, on its own, in its own world, Euro banknote, oh, there we go again. Can't stop emailing me. Mod 9. 0 mod 9 is what this should equal to. And now what we're going to do is cast out the 9s. 9, 0, 0, 0, meaningless. Any other 9s? Yay. So what I'm doing is reducing the having to sum this. Remember, the check digit is added at the end. Of course, it's already created here. But the check digit with all the other ones should end up being a number that's divisible by 9. So that is the key. Now I'm going to pick a different color. I didn't do this in the other hours. Hey, what's 7 plus 2? 9, Mr. Samuels. And then what's 5 plus 4? 9, Mr. Samuels. Okay, then I'm stuck with non-numbers or numbers that don't add up to 9. So now what I can do is add those up. All right, 6 plus 4 is 10, 10 plus 18. Is 18 congruent to 0 mod 9? And of course the answer is yes. So that means this is valid. It fit and worked in the scheme that is specific to a Euro banknote. Boy, how many times have I said that? I just want to make sure students don't make a mistake. Okay, now the classic question of find the check digit. So 1, 2, 3, 4, 5, 11, D12 check digit. First of all, we got to find W. So your job is to look at this. W is Denmark. But not only is W Denmark, this translates to a 6. I don't know why I put this way over here. I'm going to pause this and get this ready better. Okay, and actually what I should have on this is plus signs, but I don't, because this is this uses mod 9. Almost called it a mod 9 scheme. But remember, plus D12 is congruent to 0 mod 9. Oh, how many times is he going to say it until I get 100% of the students to understand the difference? Okay, so what can we do when it's a mod 9 scheme? Cast out the 9s. 9. 9. 0, of course, is useless. Oh, all right. Now I'm done. Let's get a different color and find things that add up to 9, like 6 and 3. 7 and 2. I'm excited. Yeah, what color do I choose? I think I ran out. Orange. 5 and 4. Okay, I think I got rid of everything but 6. 4 plus 2, I mean. And again, this is only because this is division by 9 that we can do this. All right, so that's why, mod 9 schemes are special and a little bit easier to deal with. So lo and behold, what would D12 have to be to make this divisible by 9, this sum? And of course the answer is 3. And I'm not rewriting the whole thing. D12 is equal to 3. Find a check digit. Okay, so D12 is equal to 3. So the whole thing would be W, blah, 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 9, 0, 4, 4, 2, 3. That would be the number. Okay, I'm going to move on. This is where am I at? Because I got to tell the students when to start watching. 1742. It's a good year, by the way. This is those special little questions where determining the missing digit. Okay. Now it is noted as a mod 9 scheme, so that means we're back to our original. That means this is what this means. We are going to 7-3 D3. That's in a different position. 1. Then we're going to mod 9 this, and that should equal 1, because that's what the check digit is. The check digit in a regular mod scheme, non-European note bank scheme, the check digit is the last digit, and it is found by modding the previous. And we know we can switch these two. So actually, what I really should have wrote is, let me write this the way I should have. I think I have the eraser, blah, 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 and I should have used congruent. This means this is congruent to 1 mod 9, because that's what a regular mod scheme does. It mods the previous, and then the check digit is the mod of all the previous digits. And because it's a mod 9 scheme, what I can do with these is add them, because any number that's divisible by 9 or has a remainder of 1 when divided by 9, this is another way I can analyze it. So this is all you have to do, and understand a regular mod scheme, and then solve this little situation. 7 plus 3 is 10, plus 1 is 11. 11 plus what gives me the next closest number that has a remainder of 1 when we divide by 9. So 18 is divisible by 9. So that would be 0 mod 9. So I need this to be 19. So I don't think I have to do equation solving for this. This would have to be 11 plus, what gives me 19? 8. So by just simple surmising, 8 would have to be the number because then that turns this into 19. When I divide 19 by 9, 9 times 2 is 18, plus 1 is 19, so that gives me a remainder of 1. So D3, the third digit, would have to be 8 to make this a valid scenario. Okay? One more. Uh-oh, didn't give me the space. There we go. Maybe a little bit more. Same old, same old. And again, I have this boxed ahead of time. But this is a 1, 2, 3, 4, 5, 6 digit mod 9 scheme. Classic mod scheme. Let's go back to the front of the notes. Where did it go? Oh, that's your bell work. There it is. All schemes noted as a mod number scheme means that the check digit is there it is mod of all the previous digits. I'm reading that red again. So that is what all mod schemes are. This is different. Oh, how many times are you going to say it? Until everyone's perfect. That's how long. So what I would have to do is mod 9 all of these previous digits, and mod 9 of all these previous digits should equal what, everybody? 7, Mr. Samuelus. So what I could do is this: 4, 5, 3, D4, 4 equals 7 mod 9, meaning when I mod 9 all the previous digits, I should get a 7. Then, of course, since it's a mod 9, I can add the digits to see what the number should be. Congruent. And then I could cast out the 9s if there are any, because it's a mod 9 scheme. So I'm going to get rid of that 5 plus 4. How exciting. And then what I'm left with, I'm staying green. D4 plus 7 equals or is congruent to 7 mod 9. Interesting. So what would D4 have to be when added to 7? So then when I divide this over here by 9, I get a remainder of 7. I hope the dog that everyone's saying D4 equals 0. All right? All right.